Greetings and salutations, my friends. I am here to talk to you now today about physical and chemical change. Now, what do we know about matter? We know that it can change. So, I've got some matter in front of me. I've got matter all around me. Everything's matter. But let's look at this matter that I have in front of me right now. And I'm going to take a little bit of matter. I'm going to take some of this Dawn soap and I'm going to pour it into this here. And I'm just going to take it in this little cup here. And I'm just gonna fill up the bottom with Dawn soap. Now, technically you could call this physical change. It's changed its shape. It's in a different cup. Now I'm gonna take some of this super cool citric acid. Ooh, you wouldn't wanna have citric acid, would you? It's orange juice. Or it could be lemonade. It is the active acidic ingredient inside of, I'm actually gonna dry this out here a little bit, because I don't want the citric acid to stick inside the cup. Now I'm going to be very scientific, and I want to get about 15 milliliters of citric acid. Now, if I was really being scientific, I'd weigh it out. But I'm not going to do that right now. I'm just going to measure it out. And the reason why I'm doing that is because I have practiced this before, and I want it to look cool. And this is about how much I figured it would be good. Now, as you can see here, it's sort of mixing in there. It's just kind of forming a little sludge, and that's not going to mix up very well, so I should put some water in here. Put in a little bit of water. And what have I made? Soapy water. Okay, now this is just soapy water, not chemical change, because it's just the same color. The soap was blue. It's a slightly lighter blue because I put water in there. Now I'm going to put it in this graduated cylinder. Why do we call it a graduated cylinder? Because it went to university. No, because it's got gradations or marks on the side so we can measure with it. Now, if I was going to do a volcano, would it be blue? No, I don't think so. I think that's kind of boring. So I'm going to make it red. Got a little red food coloring here. And a little red food coloring in here. I'm going to drop it in here. This is called a pipette. Do not call it a dropper, although you could. Okay, I've turned it red. Is this chemical change? No, it's just red. Ooh. No new color, just the same color as before. Now, if you know anything about making bubbles, you might know what I'm going to pull out next. I'm going to get out some delicious sodium bicarbonate. Saying, oh my gosh, sodium bicarbonate, I've never had that in a million years. Yeah, it's baking soda. You've had this before. And I'm gonna get a lot of baking soda. And by a lot, I mean about 15 milliliters. Look at this little shot glass of baking soda. And I'm just gonna drink it up. No, I am not gonna do that. Instead, I'm gonna mix it in here. Now, everything we've seen up to now has been physical change. Not that exciting, but it's happened. Now we're gonna see some chemical change. I hope, if I do everything right. I'm gonna drop this baking soda inside here, this acidic liquid, and let's see what happens. If there's a chemical reaction, bubbles will form. Let's see. Oh. 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 Oh no. Success. And that, my friends, is how you make a volcano. It's also known as elephant's toothpaste, and as you can see, it just keeps coming. Because when you brush an elephant's teeth, you need a lot of toothpaste. Thank you for watching my video on chemical and physical change. Peace!